Hello everyone, this is Usman Sheikh and I'm going to give a lecture on cloud computing application in the automotive industry. So this is the main component of our presentation. We will talk about the cloud computing, IoT, then we'll see some applications of cloud in the future automotive industries, and we'll see what are the benefits of implementing cloud into the automotive industries. And lastly, we will see a use case scenario of automotive sector in the Google Cloud. So these are the topics we are going to cover in this lecture. In the cloud, computing doesn't happen on our PC or the mobile device, but it happens somewhere else. So in this architecture, our mobile device or PC doesn't have much computing power. So we hand over these computing loads to cloud service providers, and they did all of this complex tasks like the data storage or uh, machine learning models, etc. So cloud computing can be called as hosted services over the internet. We can build our private cloud or the can use standard cloud service. In the private cloud, it can be composed of data centers and the proprietary networks that provide us services to uh, limited number of users and with limited functionality or access. It's a private network or the public cloud. The main objective of the service is to provide extendable or the scalable solutions for the hosted devices. The infrastructure is mainly composed of both software and the hardware components for the implementation of the cloud computing modules. Generally, there are three type of services that are available. First one is infrastructure as a service, then there is a platform as a service, then we have software as a service. Let's see how they are made in the cloud. At the bottom of this there is infrastructure as a service. It will contain data centers, networking architecture, servers and storage. But once we add the operating system into this IES, we get the platform as a service. And lastly, if we have the development tools and the hosted applications, all of this is provided by the uh, services, then we call this as, software as a service. Next, have a look of the on IoT. IoT is basically implementation for connecting different physical devices, and they are connected over the internet. These devices have the ability to transfer data to the cloud through a Wi-Fi network automatically. IoT in the automotive industry is gaining traction now, and we are now have plenty of devices which can track our vehicles. We can automatically turn on its appliances through the internet. So this is a simple architecture where we have the cloud at the center, and there are multiple devices can connect like IoT enabled factories, our homes, their smart cities, and many other available industrial and domestic devices can connect. And IoT is basically composed of data centers and networking architecture. So the reason for selecting this cloud computing in the specifically in the automotive industry is because it has large potential, and in 2022 67 billion revenue was generated from this sector, and is South Asia Pacific region is the most uh, growing region for the cloud computing applications in the automotive industry. So let's have a brief overview how cloud can be useful, how it can be used in different applications in the automotive industry, and like connected vehicles, autonomous cars, vehicle management and fleet tracking, digital marketing, or digital manufacturing. All of these are possible areas where we can use cloud computing. Let's first see how connected, what are the connected vehicles, and we'll see its architecture. So, a connected vehicle can be said to be a car, any car, truck, or bus, any vehicle then that has the ability to connect to its devices which are in the vicinity through the internet. And these vehicles having connected ability can store or share its data to other devices, and they can receive data of other devices which are nearby. So, and they also can store data over the cloud, and they can get useful information like real-time traffic conditions, weather conditions, and safe driving distance. All of these parameters can be obtained through the cloud. This is one typical example where connected vehicles can communicate to different architectures like V2C, vehicle to cloud communication, V2V. One vehicle can connect to the other vehicle through the cloud and shares data, and in a similar way, it can connect to the infrastructure V2I and V2P, vehicle to person. So these type of communication can happen in the connected vehicles. The next big area for the its application is in the autonomous cars. Autonomous cars are the self-driving cars. They are generally equipped with a lot of sensors, and these sensors are providing huge amount of data. The data is being processed somehow on the local computer, and the most of that data is transferred to the cloud. And the cloud do all the complex computation and return its result to the vehicle for the autonomous operation. In this example, we can see there are multiple sensors like GPS is used for navigation purpose and tracking. LiDAR is used for the mapping of the environment around its surrounding. The similar radars and ultrasonic sensors, position sensor, speed sensors, all of these sensors are mainly available in the autonomous cars, and these data devices are connected to the internet. The next big thing for the implementation domain is digital manufacturing. As we have seen a tremendous growth in the digital manufacturing because of the robotics, artificial intelligence, and other digital technologies, and as a result we can see a significant increase in the production, and the quality standards are highly reliable, and manufacturers which have such implementation of digital manufacturing, they can benefit from predictive maintenance, data analytics, and other options which comes with the implementation of the cloud, such as intelligent algorithms based condition monitoring, etc. This is example. Let's say we have multiple customers, 1 to n, and we have suppliers. One side we have demand, the other side we have the supply. So both of them are connected through the cloud platform. They share their requirements, and the supplier meet their requirements, like supplier are producing different products, and all of this is completely managed by the cloud platform. Vehicle tracking and fleet management is now coming nowadays. Tracking already in place. All of the vehicles which have the GPS and IoT, they can be tracked at any location at any time, and the real time location of the vehicles help us with resource allocation and better planning. So if any company have a lot of number of vehicles, they can manage their vehicles and their locations and their resources efficiently with the help of cloud implementation. This is the architecture for one example. One such example, let's we have GPS equipped vehicle which has connectivity, and it can connect to the mobile service provider, and it can send its data, its location, its sensor values to the cloud through GSM or GPRS communication, and the end user or the management company can see its live location on the mobile app or the web portal. So this is how a simple tracking occurs in any fleet management system. Now we will discuss what are the benefits of cloud implementation in the automotive industries. Some benefits are generally uh, related to the cloud, and few are very specific to the automotive industries. With any cloud implementation, one of the biggest advantages we can get a large storage space. We have to don't worry about the structure or the data centers. All of this is managed by the service provider, and we can store our data anywhere without any harm to the our data or the security. Autonomous driving can be improved with the help of cloud implementation, because the computer on the vehicle is very resource limited. We can transmit all of our sensors data to the network, and they compute all the complex things, and they return only the final output values to our the system. So cloud platform will be able to improve safety, efficiency and security of the driving cars. Security is a major consideration while implementing any device which is able to connect to the internet. And service provider of cloud computing service, they have better security and reduce risk in their architecture. They have data replication, and they have different firewalls. All of this make it error failure, and data is not. Automotive sector as a whole is composed of many manufacturers. They produce different products, and they all come to the assembly point, and they make the final product. So they need to communicate with each other through some platform, and this service can be provided by the cloud computing. Like we have the ability to communicate business to business, and collaboration is improved in their operations. With the cloud, we can see we don't have to worry about the development of our platform. All of this is managed by the cloud service provider. Shared mobility is a new concept. Somehow it is implemented in many countries. It is a type of ride sharing system in which we don't own any car or bike, and the bikes are pool cars or bikes which are shared among many users on their need. So making it more environmental friendly, and there is less congestion on the roads. So all of this can be built on the cloud-based applications, which can many users can access, and they can order any kind of service they need. Predictive maintenance is another benefit that we get from the cloud computing, because we are getting a lot of telemetry data, and we can combine these telemetry data with other available resources, and make some insights and make some predictions about the system failure which can occur in the future. So on the base of this, driver will be able to identify the any failure in advance, and they will be able to keep their vehicle maintained before any problem. Next benefit is we will be able to get customized experience for any in vehicle, like someone has his taste towards some music in its car, which is connected to the cloud, is an entertainment system which is connected to the cloud, automatically download up and play the music according to the uh, sense of the driver, and it will also help driver in navigation or path suggestions depending upon its previous experience. Moreover, it can automatically preheat and cool the cabin prior to a daily compute based on daily driving patterns. So it will be able to extract different patterns and manage the vehicle accordingly. Understanding all of the details like the benefits and understanding the applications area in the automotive industry, let's have a look at the particular examples of the usage-based insurance. We will see the components, its application, uh, how it is used in the cloud, and what are the components that are being used for such scenario. Traditionally, insurance policies for uh, basically based on how much you drive or the distance you travel will be the main components for deciding the insurance policies. But in this case, now with the help of cloud, we can also incorporate the driver behavior, because we are getting a lot of data for, from the sensors in the form of telemetry. So they can improve the risk models of the insurance. By including the behaviors of the driver, we mean how good way he is driving, how acceleration or accretions are occurring during the drive, and how the driver is taking care of the speed limits, and many other parameters can be considered. So this kind of monitoring from the vehicles can help the insurance companies to better decide their insurance claim in case of any accident or mishap. Any vehicle which has the ability to connect to the cloud will be able to produce a lot of data, like we can have vehicle location through the GPS, we can have speed limits, accelerometers, and orientation readings, and so on. Similarly, we can manage the drivetrain matrix, the speed of the engine, RPM, and fuel level and fault codes. All of these can be extracted. In the similar way, we can also manage cameras, and we can look at the temperature, location, and payload. All of these parameters can be considered for the implementation of the insurance claim. Let's have a look what are the challenges that are being posed by such scenario, like device management, data ingestion, data analytics, predictive models, and applications. These can be the possible challenges. We'll see how they need to be handled by any cloud service provider. This is the workflow of user-based insurance system that is implemented in the Google Cloud Platform. It shows the whole architecture, like at the top we have the vehicle which is cloud enabled. Then we have in the cloud, this is the device management system, which is composed of device manager, device control, and authorization service. Then we have data ingestion module, which is equipped with MQTT bridges, and it has cloud publisher subscriber service. Then on the next stage, we have data storage and data analytics. Data is normally stored in the big table, and in the analytics we have BigQuery ML module in the Google Cloud. And then next we have front end application development module, or where we have compute engine, we have app express, so we can connect to the mobile web apps or PC apps through the internet. So this is the normally architecture in the cloud, Google Cloud Platform for the usage based insurance. The first thing in the implementation is the device management. In the device management, every device should be get registered through the device manager, and when the device sends messages to authorize the device connection, they will maintain a secure connection. Once the device is registered, the device manager is responsible for monitoring them, and it can allows allow you to give any commands from the device. For the implementation of device management, every device register is produced in a specific cloud region. Like in the world, we have multiple cloud regions, like in the China, in the America, in the Europe. So every device is registered in a specific region, and that belongs to a cloud project. The device ID is defined by the user, but it also generates a numeric unique ID which is used by the cloud IoT core. So it is not readable by the user, so it is internally maintained by the cloud. The next step in the workflow is the data ingestion. Data ingestion is like moving the data from the device to the cloud after making successful communication uh, using the MQTT service. Once the vehicle endpoints are authenticated, the bridge is able to communicate between the cloud and the device through Google Cloud Publisher Subscriber Service. So this service is a globally scalable messaging queuing system, and it is excellent for handling stream of vehicle data, like we have time series data, we have images. All of these can be handled by this model. After that, the next thing is, after we have made the connection, we have subscription to the data, then we have to perform some kind of analytics, or we have to store data. For the analytics, cloud data flow have the ability to process the data pipelines that combine the vehicle device data with the corporate vehicle and customer data, and then store the combined data in BigQuery. So BigQuery is basically thing which is a powerful analytical engine in the cloud, and it do all the predictions or make all the calculations for insurance claims. And in the BigQuery, we use multiple machine learning algorithms, and all of these algorithms for prediction or the calculation, they are mainly implemented in the TensorFlow. And TensorFlow is basically a deep neural network model, and it is highly optimized for performance and flexibility and scale. All of these are achievable with the help of TensorFlow. The output of these models include the probability of a claim for a given vehicle and the predicted magnitude of the claim. Data is used as a signal in usage-based insurance risk modeling. So basically, TensorFlow models are uh, trained in a way for usage-based insurance, and they can make prediction. At the end of this implementation, like in the usage-based insurance, we will have one application which is hosted by the cloud, and that can be accessed by customer as well as company for observing or seeing how the policy is working for anyone. And customer also can sign up or discontinue service uh, on their demand. So that was a brief overview how the such insurance-based application, user-based application could be implemented in the Google Cloud, and we have seen the components that are available in the Google Cloud. So let's get into more depth. We will discuss a few components that we have seen in the previous architecture, like we can have big table storage, we can have publisher subscriber model, app engine, and so on. So first of all, we will see what is a big table storage in the Google Cloud. It is a basically sparsely populated table then that can scale to billions of rows and thousands of columns. So the main benefit is it is scalable in the rows and in the columns. We can store any data to any length regarding our requirements. Each we have in the rows we have key value, key number, and then in the column we have that value. So we work with key value, single key value data, and it has the ability to support high read and write throughput at low latency. So it is very efficient in dealing data for storing data in the key value pair. One of the major component is BigQuery that is used for data analytics. Google Cloud offer BigQuery ML as a completely serverless and cost-effective data warehouse. That means it can store data and it has built-in machine learning algorithms like neural networks, decision tree, and other learning algorithms. So this is a basic workflow. At the start, we have BigQuery data warehouse where the data is stored. Then we pre-process that data and export to train the ML model. After the training, we can deploy the model and we can extract useful information for our machine learning algorithm. Communication with the cloud is a major component, and normally this is done through two protocols. One is MQTT and the other one is HTTP. MQTT is a standard publisher subscriber protocol, and it is commonly used with embedded devices and machine to machine interactions. On the other hand, HTTP is a connectionless protocol, and IoT core is not responsible for maintaining a connection, always maintaining a connection to the Google Cloud. So they send requests and receive responses. This is like the email type systems, and the MQTT is a different model which works on the publisher subscriber. We'll see in the next slide how they are different and what are major their differences. So these are the differences. First one is device connection is maintained in the MQTT bridge. So MQTT bridge is uh, able to maintain connection. On the other hand, HTTP is a connectionless communication. We have full duplex versus half duplex. Then we can see the connection status in the MQTT bridge, and which is not available in the HTTP bridge. Also, we are able to see when the device was last time on through this bridge MQTT, and this scenario, this feature is not available in the HTTP. So let's see what is a publisher subscriber model. As in the diagram, we have one publisher, like we have streaming of data, and we have one publisher that is able to send data to many users. It will send data to the central service, the IoT core, and that IoT core is communicating the data to different subscribers. Like we have three subscribers, all of them can uh, subscribe for particular topic, and they can receive that data for their applications. This is like different microservices talking to IoT core, and IoT core is maintaining the connection between the publisher and the subscriber, and they will make connections and send the data. The last thing is app engine for the websites. App engine in the cloud is we can build different applications for the user in the different programming languages like Java, C Sharp, Go, Python, and PHP. So this is fully managed. App Engine is responsible for hosting or keeping domains of the website and maintaining all the data available to the user through its app. So these were all the components, few components that we have discussed, and we see a lot of applications of the cloud computing in the automotive industry. Throughout in this lecture we have covered different components. We began with the cloud computing, then we see the IoT things, and then we have gone through applications area of the cloud in the automotive industry, and then we have seen different benefits. At the end we have different discuss usage based insurance scenario in the Google Cloud platform. Thank you. Thank you very much.